This is chapter 12 of the C4 notes booklet, Integration by Substitution, on page 31. As usual, if you're taking notes, you'll often have to pause in order to take those notes. I won't be pausing to give you time like I would normally in a lesson. So, page 31. Now, sometimes substitution makes integration easier, but you will have to replace the dx as well as the normal function. So you would replace dx with dx by du. Now it looks like the du's would cancel, leaving you a dx. Actually, what's happening is more complicated than that, but it's a useful thing to think in terms of making sure that you set up the equations correctly. In this example, and most examples in the exam, you'll be told what substitution to use. So use the substitution u equals x squared to find the integral of 6x e to the x squared dx. So with any substitution question, the very first thing you should do is differentiate the substitution. That will immediately gain you a quick mark. So du by dx is equal to 2x in this case. And then, although du by dx is not a conventional fraction, it can be useful to pretend that it is and rearrange that to dx equals, and that will then tell you exactly what you need to substitute into the integral to replace the dx. It's not mathematically accurate. It is, however, almost like a paper trick to make sure that you do the integral correctly. So in this case, times both sides by dx. So du equals 2x dx. One dx on its own, so dx equals 1 over 2x du. And so I will place the dx with 1 over 2x du. As I say, not mathematically sound, but actually gives you the right thing to sub in. So it will be allowed on the exam. So integrating. Well, before we do so, we need to do the substitution. So u is x squared, so wherever x squared is, I replace it with u. So it's the integral of 6x e to the u, and dx I replace with 1 over 2x du. Now in this case, we get a bit of cancellation. The x's cancel, and 6 times a half is equal to 3. So the substitution turns into the integral of 3e to the u du, which is an easier integral to do than the original integral. Now 3e to the u integrates to itself. So we get 3e to the u plus c. And to finish it off, the substitution is a trick. What we want is a solution that's in terms of the original variable x. So replace the u with x squared again. So in this case, the integral integrates to 3e to the x squared plus c. So use substitution, u equals tan x to find the integral of 10 to the 4x x squared dx. So again, like I said before, any substitution question, first thing you should do is differentiate the substitution. So du by dx equals sec squared x. Rearrange the dx equals du equals sec squared x dx. Divide by the sec squared. Dx equals 1 over sec squared du. Sec squared x du. So we've got all the bits we need for the substitution. U is tan x, so we get that it's equal to u to the 4 times sec squared x times 1 over sec squared x du. In this case, the sec squareds cancel. So we end up with a much easier integral, the integral of u to the 4 du. Apply the normal integration of polynomial rules. Add 1 to the power, u to the 5. Divide by the new power, divide by 5, plus c. And then again, we want our final answer in terms of x, not in terms of u. So u is tan x, so that's tan to the 5x over 5 plus c. Now again we've got substitution, u equals 1 plus sine x. So very first step, as always, is to differentiate. So du by dx equals cos x. Again rearrange the dx equals. Du equals cos x dx. Divide by the cos x. Dx equals 1 over cos x du. Subbing in, we've got cos x, we leave sine x. Well, u isn't quite sine x, it's 1 plus sine x, but that means that sine x equals u take away 1. So we can replace the sine x with u take away 1. And then we've got 1 plus sine x squared, so u squared, times 1 over cos x du. We can then cancel out the cos x's, because this multiplication can do it in any order. Cos x times 1 over cos x is just 1. So we get the integral of u squared times u minus 1 du. Multiply it out, and we get a polynomial. U cubed minus u squared du. That we can simply integrate using polynomial rules. So we get u to the 4 over 4 minus u cubed over 3 plus c. Sub our u back in. 1 plus sine x all to the power 4 over 4 minus 1 plus sine x all cubed over 3 plus c. We don't require any kind of simplification, that is sufficient for a final answer. Last example deals with two other issues that we haven't dealt with so far. Sometimes your substitution might be u squared equals instead of u equals, and very often limits are also needed to be dealt with. So again, substitution, we need to differentiate it. Now we've got u squared equals x plus 1. And when it's u squared, there's usually a single x to rearrange to. So in this case, before differentiating, I would rearrange it to x equals. So x equals u squared take away 1. Differentiate. Dx by du is equal to 2u. And therefore dx equals 2u du. So we've got that part of the substitution. But also, as we change from x to u, these are x limits, we need to find the corresponding u limits. So when x equals 3, u squared equals 3 plus 1, which is 4. So u equals 2. Now, some people might say that when square rooting, it could have been plus or minus 2. In any question you get in the exam, to avoid that complication, you can just take the positive square root in these cases. There are more complicated integrals where it could have been the negative square root, but the process of working that out is beyond the syllabus. So if there's a square root and changing the limits, you can take the positive square root. Same for the other limit, x equals 0, so u squared equals 0 plus 1, which is 1. Square root, again take the positive limit, so u equals 1. So changing everything from x's to u's. So 0 gets replaced with 1, 3 gets replaced with 2. And it must also be noted, in a substitution, it can turn out, because of the way the formula works, that the biggest number ends up at the bottom and the smallest number at the top. You need to be consistent. If 0 matches with 1, then 0 needs to be replaced with 1. 3 is replaced with 2, so the 3 is replaced with 2 in the integral. Right, continuing. Right, I want to get rid of that x, so from this, rearranging x equals u squared minus 1, so I can replace that in the numerator. In the denominator, u squared equals x plus 1. Well, we've got x plus 1 to the half, so that would make u the denominator. And we're timesing by 2u du. We get a bit of cancellation, those u's cancel out. We need to multiply through by 2. So we're integrating 2u squared minus 2 du. So integrating term by term, increase the power by 1, divide by the new power, 2u cubed over 3, minus 2 becomes minus 2u. We've got our new limits. And by the way, just as an aside, an alternative to changing the limits to u is to keep the x ones, but at these stages where we switch to du, we should write x equals 3, x equals 0, x equals 3, x equals 0, x equals 3, x equals 0. But then on the next line we could replace the u's with x plus 1 to the power of a half and then stick the x values in. Now I find it much easier if you replace the x's in terms of u's early on and then just use those limits for the rest of the question. So I've done it the way I prefer, though it is possible, as I say, to keep the x limits and then just switch back to x at this stage. But my way, stick the 2 in first. Take away, put in the 1 in. And then just, okay, sticking into calculator. Usually we want exact answers in C3. C4 as well. And as an exact answer, we get 8 over 3. And this concludes the section on integration by substitution.